Okay, in this lecture we're going to talk about some special kinds of functions called piecewise-defined functions. Now, as the name suggests, all right, piecewise defined means that the function is defined differently for different pieces of its domain. You've already struck one of these kinds of functions before. In fact, the absolute value function is indeed one of these kinds of functions, because the absolute value function is defined as x when x is greater than or equal to 0, but negative x when x is less than 0. Now, if you look at this particular example, here we have a similar situation. The function is defined as 4 minus x if x is less than 2, and 1 plus 2x when x is greater than or equal to 2. So you can see here that 2, all right, is the point where we have a change in the definition. So let's have a look at what happens when x is less than 2. Well, when x is less than 2, what sort of values do we have? So we're going to look for when x is less than 2. What sort of values do we have? Well, what if x was equal to 1, for example? I'd have 4 minus 1, which would be 3, would be my y value. So that would be here. All right, what about when x is equal to 0? That's less than 2. All right, well, 0 would mean it's 4. So you'd have 0, 4. What if x was equal to negative 1? That's less than 2. Well, negative 1 would be 4, subtract negative 1 would be 4 plus 1, which would be 5. So you can see here that it's clearly going up this way as a straight line. Now, the interesting thing is x is less than 2, well, we could have something like 1.999, okay? And we can get as close to 2 as we like and evaluate it, but it's a little bit difficult. So what we do is we cheat a little bit, and we say, well, let's imagine I could have x is equal to 2 for this function. Then I'd have 4 minus 2, which would be 2, which means I'd have this point as 2, 2, but I can't have the point because I'm not allowed to have that value for that function. So I'm going to put an open circle and then connect it up. Okay, so we're getting as close to this point 2, 2 as we like without actually being there, and that open circle represents that, and the rest of the function just goes this way from then on. Now what happens, so in other words, we'll put our y values in here. So when it was 1, it would be 3. When it was 0, it would be 4. And when x was negative 1, it would be 5. Okay? If we allowed x is equal to 2, then it would be 2, which would be 2, 2. So we use an open circle there. Now when x is greater than or equal to 2, we're allowed to have 2 in this case. So what would I have when x is equal to 2? Then I'd get y would be 2 2s are 4 plus 1 is 5. So I'd end up with 5. So I'd end up with the point 2, 5. And we'd have that point right there. Now, what about when x was equal to 3? That's greater than 2. So it would be 2 times 3 is 6 plus 1 is 7. So I'd have 7. And so forth. And of course, we could keep going. X is equal to 4. So here y was equal to 7. And when x is equal to 4, I'd have 2 4s are 8. Plus 1 is 9. So I'd have 4, 9, which is here. So in other words, my function would go up like this. And that would be a graph of my piecewise function, which is defined in this way. So notice we have to consider, all right, the parts of the domain, or the pieces of the domain, all right, either side of where it changes, and use the appropriate function in each case for those points. Right, let's look at a more difficult one. This one we have 3 definitions. We're going to have it changing at negative 2 when x is negative 2, and also change again when x is 2. All right, so let's look at have a look now when x is between negative 4 and negative 2. Now notice we're allowed negative 4 and negative 2, and you can see that this is a squaring function. And so if I now take, say, x is equal to -4, what's my y value? Well, it would be -4 squared, which would be 16, and half of 16 would be 8. So it would be -4, 8, which is right here. Right, now what happens if I do somewhere in between here, like -3, if I put -3 in here, what do I get for the y value? Well, -3 squared is 9, and half of 9 is 4.5, so we'd end up with this value here. Okay, when I have, so y is equal to 9 on 2. Okay, now when x is equal to -2, we're allowed that one as well. Then we have -2 squared is 4 divided by 2, we get y is 2. So -2, 2. So this is a parabola. Now remember that it ends here. Notice the domain ends here, so we can't go any further. So we've got this curve, it's actually a curve, like so. Alright, so that's our first part. Now our second part is when the function is equal to x. So we're looking for when this is between -2 and 2. And the function we're looking at is f of x equals x. So this shouldn't be too hard, because if I was allowed, so that's where we cheat a little bit, if I was allowed to have -2, then of course the y value would in fact be, so let's put it here, -2, then y would in fact be also -2. So we'd have this down here, but we'd have to use an open circle because we're not allowed to actually have x is -2. Right, now this is now the identity function, as you can see. So when I go to -1, of course it'll go to -1. And that's between there. 0, it would go to 0. 1, it would go to 1. Now we're not allowed to have 2, but if we were allowed to have 2, then we'd go to 2, so we would put an open circle there. And we'd join this up as a straight line. Alright, so that's the next part. So when we had x is equal to -1, we'd have y as -1. When x was equal to 0, we'd have y is equal to 0, and so forth. X equals 1, we'd have y equals 1, and of course so forth. We did try this one and cheated a little bit, and we'd have that. Alright, so we've got that. Now the next part of the domain is between 2 and 3. And this time the function we're looking at is f of x equals x squared minus 4. Alright, so we're allowed to have 2 here. So when x is equal to 2, we would have 2 squared is 4, minus 4 is 0. Right, so I'd have 2, 0, which of course is right here. Right, when x was equal to, we get between 2 and 3. Well, when x is equal to 3, what would we have? We'd have 3 squared, which would be 9, minus 4 would be 5. So I'd have 3, 5. And so this is our parabola here, like so. Now we don't go any further because the end of our domain is in fact 3. And this now is our graph of this piecewise defined function here. Now, a couple of things about this. The domain of a piecewise defined function can be found by just looking at these inequalities. Okay, so in actual fact, this is all the real numbers. Okay, so the domain here is all the real numbers. Now, if you look at the range, though, okay, the range, however, right, is the y values, and the smallest y value is 2, but it's actually not 2 because it's an open circle here. So it is from 2 all right, and this goes up then forever, and so it's going to be from 2 to infinity. Not including 2 because that's an open circle. Right, if you look at this one here, what is going to be our domain? We can see our domain is really going to be from -4 all the way through, covers everything up to -2. Then from -2 to 2, then we pick up the value 2 here to 3. So in other words, the domain here is in fact from -4, including -4, to 3, including 3. So really -4, 3 is the domain. Now the range here, all right, is going to be, well, the lowest point here is -2, but it's not including -2 because of the round circle, open circle. Then after that, everything seems covered. All the y values seem covered from here to here until we get to the highest one, which is 8. So that will include 8, and so we have that. Right, now one of the things we need to be able to do, as you can see here, is to be able to determine the value of y at specific values of x. And so we have to do that by looking at where that x value falls. Now, if I'm looking to find f of -5, I have to look in here and say, well, where does -5 fall? Well, -5 is less than -4, so it's this function here. So this will be 2 plus x, which is -5, which of course is -3. All right, next one, -1. Well, -1 falls in between -4 and 2, so it's this one here. So this will be the negative of -1, which of course be 1. 0 also falls between -4 and 2, so this will also be the negative of 0, which of course is still 0. If I'm looking at f of 3, then notice that 3 is greater than 2, so it's this function, so it's equal to 3 by 3, which is equal to 9. Okay, so that's how we graph piecewise-defined functions and how we evaluate points, function values, all right, at particular x values for a piecewise-defined function.